Uh, good day, class. I hope you're fantastic. Today, it's been a while, guys. It's been a while, but today we're going to be focusing on the eye, right? Going to be focusing on the eye. This is a very challenging chapter, as per life sciences students. Like they really struggle with this chapter, so I felt like it's important for me to record this video. Let's start right away without wasting time. So let's look at the external structure of the eye, right? So the external structure of the eye, start with the protection of the eye. So the eye is protected by the eyelids, right? You have your eyelids here, then at the tip end of your eyelids, you have your eyelashes. What's the importance or what's the function of the eyelids and the eyelashes? So the function of the eyelids and the eyelashes is to protect the eye from foreign objects, right? So it's protecting the eye from foreign objects. Does that make sense? Okay, so that's how the eye is protected. Then within the eye, right, the corner of your eye, we have obviously you can't see them. We have like lacrimal glands, right? The glands that produce tears. The tears they do the same job, right? So they moisturize the eye, they prevent the eye from being dehydrated. Moreover, they remove foreign objects if it happens that those foreign objects enter your eye, right? And also at the corner of your eye, there's a fatty tissue, right? That cushions your eye. It cushions your eye. Does that make sense? Let me just continue, right? Or just go back and try to explain it. You have your eyelids. These are your eyelids, right? Then at the tip end of your eyelids, you have your eyelashes. What's their job? They prevent foreign objects from entering the eye. I hope that makes sense. Moreover, you have in your eye, you have your lacrimal glands. Your lacrimal glands, they produce tears. What's the function of tears? They remove foreign objects if it happens that they enter your eye. Furthermore, they moisturize your eye, protecting it or preventing it from dehydration, right? And then at the corner of your eye, there's a fatty tissue, right? That fatty tissue cushions your eye. It acts as a cushion, right? Let's continue. What else do you see when you look at the front view of the eye, the external structure of the eye? You see the pigmented part here called the iris, right? So this is the pigmented part. So what's the function of this iris? So the function of the iris is that it absorbs the sun or the light, the sunlight, right? Or let me just say light, not sunlight. It absorbs light in order to prevent internal, right? Internal reflection of light, right? That's the first function of the iris. What's another function? Another function is that it controls the amount of light entering the eye. How does it do that? It does that by means of muscles. So within the iris, we have two muscles, right? You have your circular muscles and you have your radar muscles. We'll get to pupillary mechanism and explain the whole process. What else do you see in the front eye, in the front view of the eye? You have this opening at the center of the iris. So the opening at the center of the iris, what's its function? So it allows light to enter the eye. So it's controlled, the pupil is controlled by the iris. It's at the center of the iris. It's controlled by the iris, right? That's allowing the amount of light entering the eye. And there's this white layer you see here. The white layer is called the sclera. And what's the function of the sclera? We're going to repeat the function when we get to the um, internal structure of the eye. So what's the function of the sclera? The function of the sclera, this white inelastic layer, it's called the sclera. What's the function of the sclera? The sclera protects the inner parts of the eye. It protects the inner parts of the eye. Or you can say also it maintains the shape of the eye. So we're done with the external structure of the eye. Let's just continue. Let's continue and go into the internal structure of the eye and explain each and every function. So the eye is divided into three layers, right? So the first layer is the sclera. This layer, if you can see it, look at my pointer here. The sclera, you see the sclera. So what's the function of the sclera? The sclera protects the inner parts of the eye, right? What's the structure of the sclera? The structure of the sclera is that it is white and inelastic because it protects the inner structures of the eye. It also maintains the shape of the eye. As you can see, it's the first layer. Right? Now let's go to the second layer. This is the second layer, this pigmented layer that is filled with blood vessels. This pigmented layer, which is called the choroid. Follow my pointer, the choroid. The pigmented layer, what's the function of the choroid? So the function of the choroid is that it absorbs, it's a layer, it absorbs light in order to prevent internal reflection of light. So it absorbs light. It is pigmented, it is brown in color, right? Even though here it might not seem brown, but it's pigmented and brown in color, right? And also it contains blood vessels. Why? Because it provides nutrition for the eye. The reason why it contains blood vessels, because it provides nutrition for the eye, right? Let's go to the third and final layer. So the third and final layer, you have your retina, this yellow part. Your retina is the third and final layer. So what do you find in your retina? In your retina, you find photoreceptors. Photoreceptors. What are photoreceptors? Photoreceptors are receptors that receive the light stimulus and then convert it into an impulse. I hope that's clear. What do we call those receptors? We have two types of receptors, photoreceptors in the retina. We have your rods, which deal with black and white, right? Which help you distinguish between black and white. And the second type of photoreceptors you have cones. So cones, they deal with bright colors. For you to be able to see color, cones are responsible for that. So they're responsible for bright color, right? And then there's this in your retina, right? In the eye's retina, there's this depression or decline, small decline. That's called the yellow spot. Yeah. This is where you find the highest concentration of cones. You find the highest concentration of cones. I hope that makes a lot of sense. This is where a clear image is formed, right? And then still, we, as we still in our retina, in the retina you find another part, which is the opposite of the yellow spot. You find the blind spot. So in the blind spot, you don't have any rods or cones. So there are no photoreceptors in your retina, in your blind spot rather, right? Okay, so we are done with those three layers. Let's go back to the first layer, to the sclera. So as you can see, if we can move along and extend with the sclera into the front eye, you can see that the sclera, it extends into this front layer that is convex, called the cornea. It extends into the cornea, right? So it extends into the cornea, this convex layer. Remember, convex, what does convex mean? Convex means that it extends outward. So it curves outwards. So it curves outwards. Let me put it like that. Convex means that it curves outwards. Does that make sense? Right? So what's the function of the cornea? But let's look at the structure of the cornea. The cornea is convex. Why is it convex? Because it helps in the refraction of light. So it helps in the refraction of light. And also the cornea is transparent. Why is it transparent? Because it allows light to pass through. Anything that's transparent allows light to pass through. I hope that makes a lot of sense. It allows light to pass through. Okay? Then behind, there's this fluid that's behind the cornea. The fluid is called the aqueous humor, the fluid that's behind the cornea. What's the function of the fluid? What's the function of the fluid? So the function of aqueous humor is that it maintains the shape of the cornea. As you can see, it's just behind the cornea. This fluid, this whole fluid, if you can follow my pointer, right? This whole fluid is just behind the cornea and it maintains the shape of the cornea. And also it provides nutrition for both the cornea and the retina behind, right? This retina. The iris, not retina, the iris rather. My apologies for that mistake. So it provides nutrition for the cornea, for both the cornea and iris, right? This is the iris. This is our iris, right? Remember, this is a side view of the eye. So it provides nutrition for both the cornea and the iris. While still on our aqueous humor, the aqueous humor is also transparent because it's a fluid. Why is it transparent? Because it allows light to pass through. And it also helps in the refraction of light. Refraction, by the way, in life sciences, it means that it helps in the bending of light. Okay? Now let's move from this fluid. There's this part, this pigmented part, right? This one is pigmented. If you can follow my pointer, pigmented part. This pigmented part is called what? The iris. The iris. Right? What's the function again of the iris? Is that it absorbs light in order to avoid internal reflection. Right? Internal reflection. And another function, the most important function, is that it controls the amount of light entering the eye. And it does that by means of muscles. Remember, we spoke about two muscles that form the iris, your sacral muscles and your radial muscles. Okay, we'll focus on those muscles when we get to pupillary mechanism. Then at the center of the iris, the space, you can see the space, the center of the iris, you have your pupil. So what's the function of this pupil? It allows light to come through. It allows light to get into the eye. So it's like a gate, which is controlled by the iris. It's at the center of the iris. It allows light to uh, enter the eye. Okay? Then behind your pupil, you have your lens. You see this transparent and biconvex structure, right? What's the function of the lens? Before we focus on the function, let's look at the structure of the lens. The lens is biconvex on both sides, right? So you can see it's biconvex. Biconvex. Why is it biconvex? Because it refracts light. It assists in the refraction of light. So something that's convex or biconvex, it will refract light inwards. It will just refract light inwards. Does that make sense? So let me, I don't know whether I can be able to draw here, but it will refract light inwards, right? Focusing the light on the yellow spot because it is, right? It is biconvex. Can you see? Even though my drawing is not that perfect, right? Let me just try to draw it better. Let me try to draw it better. So it will refract light inwards, right? Try focusing it on our yellow spot. Even though our yellow spot, just know that it focuses the light on the yellow spot. So this is our yellow spot. My drawing is not that perfect. I'm not doing justice to drawing, but it focuses the light here on our yellow spot, right? Okay, try to clear this. Okay, let's continue. It's biconvex. Why is it biconvex? Because it refracts light, focusing it on the yellow spot where a clear image is formed, right? Then after that you have our the lens is transparent and biconvex. Before I continue, why is it biconvex? Because it refracts the light, helps it assists in the refraction of light, and also it is transparent because it allows light to pass through. So our lens is held by our suspensory ligaments. As you can see with the suspensory ligaments, they hold the lens in place, right? And they also alter the shape of the lens, right, in order to form a clear vision for an image that's less than 6 meters and an image that's more than 6 meters. We'll look at that process. That process is called accommodation. Right? We'll look at the function of suspensory ligaments, right, when we get to accommodation. And the suspensory ligaments, in turn, they're held by the ciliary body. Here, this is the ciliary body. Yeah, right, they are held by the ciliary body. So the ciliary body holds the suspensory ligaments in place. The ciliary body holds the suspensory ligaments in place. And within the ciliary body, you find the ciliary muscles, which play a role when it comes to accommodation. We'll get to accommodation just in a minute, right? So let's move. Let's move from these parts and let's go behind the lens. So behind the lens, we have this jelly-like layer. This jelly-like layer behind the lens is called which is called the vitreous humor, right? The vitreous humor. It's a jelly-like layer, and it contains blood vessels. As you can see, these blood vessels here. You can see the blood vessels that are here. Why does it contain, right? Why does it contain blood vessels? Because it provides nutrition for the retina. So it provides nutrition for the retina. Does that make sense? And it also, as you can see, it fills the whole eye. It fills the eye, the whole eye. Why does it fill the whole eye? It's a jelly-like layer because it maintains the shape of the eye, right? Which means that without this fluid, your eye will just be, without this jelly-like layer, not fluid, without this jelly-like layer, your eye will just be a void, right? Will just be a void, a space without anything inside to hold it. So it maintains the shape of the eye. Then behind this vitreous humor, this jelly-like layer, you have at the tip end of your retina, right? Or we can say at the back of your eye, you have this optic nerve. You have this optic nerve. What's the function of this optic nerve? So the function of this optic nerve is that it transmits, let me use transmit, it transmits impulses from the retina to the cerebrum, where the sensation of seeing is interpreted. right? So where the impulses are interpreted. So after the light stimulus here, after a clear image is formed at your yellow spot, your photoreceptors will do what? Will convert that stimulus into an impulse, and then that impulse travels along the optic nerve to your cerebrum, right? Which is some part of your brain here. Try to draw it like this, right? Right, transfers those impulses to your cerebrum. I hope that makes a lot of sense. Let me just erase this. Okay, I'm done with the internal structure of the eye. Okay, let's move. Let's do this. Okay, here they're going to explain the very same parts I've just explained. So I won't go over them again. This is just a summary of all the structures that I've just explained, right? And their structural adaptability. How are they structurally adapted to perform the function, right? So let me just move this. Let's move on. So still explaining the internal structure of the eye, right? Let's go to binocular vision. What is binocular vision, right? What is binocular vision? So binocular vision refers to the ability to focus on an object with both eyes, thus creating one image, right? So I'm sure you've noticed that your eye, there's some distance, right, between your two eyes, right? Your two eyes are able to create separate image, so separate images, right? So each eye means that each eye is able to form its own image, right? Thus creating two separate images. Moreover, the two eyes are able to create two images and make that image and combine, integrate that image so that it is one. So that it is one, right? And when your eye combines these two images, it forms a three-dimensional view. And what do we call that three-dimensional view? We call that three-dimensional view a stereoscopic view, right? We call it a stereoscopic view. Now, what's the significance? So when we say the stereoscopic view is that you can see the size and distance, moreover the depth of the image you're looking at, right? So the depth, size, and distance, right? Let's look at the importance. What's the importance of, let me do this. What's the importance of our binocular vision? Bi means two. Remember, bi means two. Bi means two. Bi means two. So what's the importance? What's the significance of our binocular vision? Is that it enables us, right, to walk downstairs. Or you can say, what's the importance of a stereoscopic or a three-dimensional view? It allows us to walk up and downstairs, right? Upstairs and downstairs. The second point is that it gives us a wider field of view. We're able to see a wider field of view. What's the next point? Next point is that it gives us a precise depth perception, right? Depth perception. So what is depth perception? Depth perception is size and distance, right? Moreover, the last point, binocular vision helps us with performance skills such as catching, grasping, and locomotion. Locomotion is movement, right? It's motion, it's moving, it's movement, it's moving. So that's the importance of binocular vision. Let's go to accommodation, right? So what's accommodation? So accommodation is the ability of the lens, because we're speaking about the lens whenever we're speaking about accommodation. So it's the ability of the lens to alter its shape for a clear vision, right? With regards to an image that is less than 6 meters or more than 6 meters. So it means that the lens is able to alter its shape, right, regarding how far the image is, right, so that you can see that image clearly. Okay, so let's look at accommodation. Accommodation is the focusing of light on the retina. So the light is focused on the retina. It's focused on a specific spot on our retina, right? I hope that makes sense. So mammals focus by changing the shape of the lens. So the lens is altering its shape in order to create a clear vision, right? So here they're saying that the lens is less convex for distance vision. So for distant vision, the lens is less convex. Remember, convex means that it curves outwards, as we saw the structure of the lens. Right? The last point is that the lens is more convex for a near vision. So for a near vision, our lens becomes more convex. So how do you differentiate between a distant object, right, and a near object? By looking at the shape of the lens. So for a distant vision, I'm going to repeat that again. For a distant vision, our lens, as you can see our lens here, let me just do this. As you can see our lens here, our lens for a distant vision becomes less convex, right? Becomes less convex. And our lens for a near vision, it becomes more convex. It'll become more convex, right? When it becomes more convex, it'll increase, right, the refractive power. So it means that it will refract light even more. So light will enter your eye and it will refract light even more, right? But when it is less convex, it will refract, the refracting power of the lens will decrease. Okay, let's continue. Let's get into the process so that I can show you the process. Not jump there. Is this thing moving so fast now? Okay, now let's look at our accommodation. So let's look at accommodation when an object is more than 6 meters away, right? More than 6 meters away. But before we start getting there, let's look at the parts, the structures that are involved in accommodation. So the structures that are involved in accommodation are your ciliary muscles, right? Remember, within the ciliary body, you get your ciliary muscles, which are this. Here, these are your ciliary muscles, right? Then underneath your ciliary muscles, you have your suspensory ligaments, right? You have your suspensory ligaments here, right? So these are suspensory ligaments, and your suspensory ligaments in turn they hold your lens, right? Your lens. What are they trying to do? They're trying to focus light. Let me draw this. They are trying to focus light on your retina. They're trying to focus. Let me just draw that properly. Right, so let me just draw that properly. They're trying to focus. Let me just draw this light. They're trying to focus light directly on your retina, right? Trying to focus light on your retina. I tried, guys. I tried. This pen is acting on me now. It's me who's not uh, acclimatized to using the pen, right? So they're trying to focus the light on your retina where a clear image is formed, right? Let's Okay, let's continue. And so what happens when an object is more than 6 meters away? So your ciliary muscles, they relax, right? They go back to their relaxation state. So they relax, as you can see, your ciliary muscles are relaxing. And when your ciliary muscles relax, right, they do what? They make your suspensory ligaments taut or taut. Let me just say taut. Taut, you can either say taut or tight, right? As you can see that your suspensory ligaments, they become tight, right? And that increases the tension on your lens. It increases your tension on your lens. And when it increases your tension on your lens will become less convex. Less convex. And when your lens becomes less convex, then the refractive power, remember refraction is the bending, is when you're bending, the bending power, right? The refractive power, right, of the lens will decrease. So it means that your lens will refract light. Um, Let me just draw it, right? So it means that your lens would refract light not as much. It will it will refract light in a, let me, let me try to put it like this. How can I put it like, how can I put it? It will not refract or bend light as much, right? It will not bend light as much. Let me just put it that way. So it will not bend light as much, right? Okay. Then a clear image will be formed where? On your retina, because this is where an image is formed, right? Okay, now let's go to an object that is less than 6 meters away. So your ciliary muscles will do the opposite, they'll contract. As you can see now, in size, they're a bit bigger in size. And you see the difference, they're a bit bigger. And when they become bigger in size, right, they force your suspensory ligaments to slacken. So your suspensory ligaments will slacken or they will become loose, right? And when your suspensory ligaments become loose, they decrease the pressure or they decrease the tension on your lens. And when they decrease the tension on your lens will become even more convex. And you see that the lens here is more convex as compared to this image for an object that is more than 6 meters. So here in this image, your lens becomes more convex. And when it becomes more convex, it means that the refractive power of the lens or the bending power of the lens will increase, right? So the refractive power on the lens will increase. And when the refractive power on on the lens is increased, it increases its bending power. So light is bent more, right, to focus here on your retina. Then a clear image is formed, right? But the important thing that you should be able to know is your ciliary muscles, they relax. Look at your ciliary muscles, right? And that causes your suspensory ligaments for an image. Let's look at the image that is for an object that is more than 6 meters, right? 6 meters away. I'm just summarizing what I said, right? So your ciliary muscles will relax, right? Which will cause your suspensory ligaments to become tight. And when your suspensory ligaments become tight, they increase the tension on your lens, right? And when they increase the tension on your lens will become less convex. And when your lens becomes less convex, its refractive power decreases. Thus refracting less light towards thus refracting or bending light, right? Not that much towards your retina. Okay, let's go to an object that's less than 6 meters. Your ciliary muscles, as you can see, they become bigger in size, right? Ciliary muscles will contract, right? And when they contract, they cause your suspensory ligaments to become loose or to slacken. And when your suspensory ligaments loosen, they cause your lens to become more convex because they decrease their tension. It cause your lens to become more convex. When your lens becomes more convex, right, it increases its refractive power. So it means that light will be bent more, even more. Okay, let's continue. Okay, so this is just a summary of accommodation. So look at your ligaments. Your ligaments, they become tight for what? For an object that is more than 6 meters. So look at the your ligaments here. Can you see they become tight, right? They become tight. And when they become tight, they cause your lens to become even less convex, right? And when your lens becomes less convex, that decreases its refractive power, right? Then a clear image is formed. But when it comes to an image that is less than 6 meters, you see here, when it comes to an image that is less than 6 meters, your suspensory ligaments, they become they become loose. As you can see, they loosen. And when they loosen, they cause your lens to be more convex, and that increases its refractive power. So it means that light will be bent more, right? Just to repeat that again, for an image that is more than 6 meters away, right, more than 6 meters away, the reason why I'm repeating is so that if I made a mistake at first, I can then fix that mistake, right? Because sometimes I say things without hearing myself, right? And that's an honest and genuine mistake. Right, sometimes I don't notice myself when I make this mistake, but that's why I repeat stuff most of the time. So look at the suspensory ligaments for an object that is more than 6 meters away. So they will become tight, and when they become tight, they cause or they force your lens, right, or they alter the shape of the lens to become less convex. And when your lens becomes less convex, your lens decreases its refractive power, right? But when it comes to an object that is less than 6 meters, your suspensory ligaments, they loosen or they slacken, right? And when they slacken, they cause your lens to become more convex. And when your lens becomes more convex, it increases its refractive power, right? So the refractive power and or the bending power of the lens increases, right? Okay. Now let's look at this image, right? For a distant object. As you can see, the image for a distant object, as you can see that your lens is less convex, right? So your lens is less convex. Does that make sense? In your lens, when it becomes less convex, it focuses the light on your retina where the clear image is formed. Now let's look at your lens for a nearby object. As you can see that your lens is more convex, right? Why is it more convex? So that it increases the refractive power, thus focusing the light directly on your retina, right? Okay. Okay, now let's go to pupillary mechanism. So pupillary mechanism, we are focusing only on our iris and pupil. Remember our iris, we said it's that pigmented layer in the eye, the layer that gives your eye color, right? And within your eye, within the iris, you find two muscles. You find circular muscles, they're circular in nature, that's why they're called circular muscles, right? And your radial muscles, right? Your radial muscles. Yeah. So you find two muscles, your circular muscles and your radial muscles, right? Your radial muscles. So your circular muscles will be like this, so, right? Just around your iris, uh, no, right? Your circular muscles become like this, right? Even though I'm not doing justice to this, and your radial muscles will enter like this, spike in like this, right? Or spike in like this. Okay. So remember, we are only focusing on the iris when we speak about pupillary mechanism. Just do this. Pupillary mechanism, right? So what is pupillary mechanism? So pupillary mechanism is when your iris controls the amount of light that enters the eye by controlling the size of the pupil, right? As you can see here, that during when you're exposed to bright light, your pupil becomes small, right? Your pupil, look at the size of the pupil, right? You can also test this out, right? Whenever someone exposes bright light or whenever you look at the sun directly, your pupil becomes small, right? It becomes small. But average, when it comes to average light, when the light is no longer that bright, then your pupil will try to increase in size, allowing more light to enter the eye, right? And when you're exposed to dim light, your pupil utterly opens up, right? So it utterly opens up. As you can see, the size of the pupil here, because you're exposed to dim light, in order to allow more light to enter your eye. And the size of the pupil is done through the functioning of your circular muscles. When you see your circular muscles that are entering your eye, right? These circular muscles rather, circular muscles that are circular, right? And your radial muscles, right? These radial muscles, right? Radial muscles. So you have two types of muscles that are responsible for controlling the size of the pupil. You have circular muscles and radial muscles. Okay. Now let's look at your pupil, your muscles, or your iris um, whenever you're exposed to bright light, right? So in bright light, your circular muscles they contract. And one thing you should remember, guys, your the muscles that you find within your iris they work antagonistically. So when one contracts, the other relaxes, right? So when you're exposed to bright light, the circular muscles of the iris will contract, right? And the radial muscles will relax, right? And when your radial muscles relax, they force your pupil to constrict. Constrict means to become narrower, right? Constrict means to become narrower. Can even write it with this thing. Can even write with this thing. Narrower. So they become narrow, right? It's my O, my fancy O here. So they become narrow, right? So they become narrow. So constricting is that they become narrow, or they become smaller in size, right? In order to allow less light to enter your eye. Because if that does not happen, then it means that you'll be exposed to a lot of light in your eye, right? And we don't need that. So your pupil will constrict or become narrower. And when it becomes narrower or smaller in size, it allows less light to enter your eye so that your eyes are not damaged, right? As you can see, your circular muscles, these are circular, they go circular like this. They go circular, right? So these are your circular muscles, right? So look at your circular muscles, they go circular around your iris, right? secular, as you can see, and these are radar muscles, the ones that enter, right? Ones that enter your radial muscles. So your secular muscles, they contract when you're exposed to bright lights, and your radial muscles, they relax. And radial muscles, they relax, which forces or causes your pupil to constrict or become narrower inside, thus allowing less light. Thus allowing less light. Okay, now let's go to dim light. What happens to your pupil when you're exposed to dim light? Your secular muscles, they do the opposite. They relax, right? They do the opposite of what they did when you were exposed to bright light. They relax, they go back to their relaxation state, to their resting state. So they relax because to relax is to rest, right? So they relax, secular muscles relax here, right? Then what happens to your radial muscles? Your radial muscles, they contract, right? Radial muscles, they contract. And when they contract, they cause your pupil to dilate. Dilating means that it becomes wider, right? Wider. So it becomes bigger, right? Does that make sense? So as you can see that the size of the pupil becomes bigger, right? And when it becomes bigger, it allows more light to enter your eye. And when more light is entering your eye, right, is when you're exposed to dim light, right? So it's easy to memorize these processes, especially pupillary mechanism. It's much easier as compared to accommodation because accommodation has a lot of points. But both processes are easy, right? Let's just continue. Now let's focus on the differences between accommodation and pupillary mechanism, right? Okay, when it comes to accommodation, right, the stimulus is the change in the distance of the object from the eye. So now we're speaking about the distance, the change in the distance, right? But when it comes to pupillary mechanism, so pupillary mechanism rather focuses on the stimulus of change in the light intensity. So whether the light is bright or dimmer, right? Now let's go into the parts that are involved. So the parts that are involved in accommodation are your lens, suspensory ligaments, and ciliary muscles. But when it comes to the pupillary mechanism, you have your pupil, iris, right? Iris, which is composed of radial muscles and secular muscles. Okay, now let's look at the main changes. So the main changes are the shape of the lens, right? When it comes to accommodation, and when it comes to pupillary mechanism, is the diameter of the pupil, right? So the diameter of the pupil. Okay, now let's go to what brings about the change. So what brings about the change or the parts that are involved when it comes to accommodation are the suspensory ligaments and lastly the ciliary muscles. But when it comes to pupillary mechanism, you have your radial muscles and your secular muscles. Okay, let's continue. Let's go to visual defects, right? Defects we have in the eye or defects that cause you to see things blurry, right? To see a blurry vision. Okay. The first thing we have, and the first defect we have, is myopia, right? It's myopia. So myopia, as you can see that, what is myopia or short-sightedness? It means that you can see things up close, but you can't see things that are very far. So you can see things that are up close, but you can see things that are very far. What causes that, right? What causes that is that your lens fails to become less convex. So your lens is always more convex. Does that make sense? Your lens is always more convex. So it's failing to become less convex, right? And your eyeball, as you can see, the eyeball is longer than normal. Is longer than normal. And when your eyeball is longer than normal, it causes the light to to be in front of your retina, right? So the image falls in front of the retina because the eyeball is longer than normal. As you can see, the image falls in front of the retina. Why? Because your eyeball, or the eyeball in short-sighted people, is longer than normal. And the lens is failing to be less convex. So your lens is always more convex. And that causes the image to fall in front of your your retina. That causes the image, right, to fall in front of the retina. Okay. Okay, now let's go to the treatment with regards to short-sightedness, right? So the treatment with regards to short-sightedness is concave lenses, or you can say biconcave lenses, right? So the biconcave lenses, remember, something that is concave, it means that it curves inwards. So it's the opposite of convex. So concave means that it curves inwards. So concave lenses will extend light outwards. You see, they extend the light. Let me just draw this. So they extend the light outwards, right? And when the your light gets to your lens, and then your lens will focus the light in your retina, right? In your yellow spot to be specific. So let me do this. The yellow spot. But they're already showing you here, right? So there's no need for me to draw it again. So your concave lenses, they will extend, or they will bend, they will refract light outwards. When the light gets to your lens, then your lens will focus the light on your retina, right? On your retina. Okay, so how do we fix short-sightedness? We fix it with concave lenses. Concave lenses. Okay, now let's go to our second defect. Our second defect is long-sightedness. So it's the opposite of short-sightedness, or hyperopia, right? Hyperopia. So long-sightedness. So let's look at long-sightedness. So long-sightedness is when you can see objects from far, like objects that are further than 6 meters, or that are far away, that are farther away, but you can't see images that are closer, right? So you can't see images that are closer to you or less than 6 meters. You can see objects that are further away, but you can see objects that are closer. Does that make sense? Why? Because your lens fails to become more convex, right? So your lens fails to become more convex. And also look at this, your eyeball, the size of the eyeball. So it means that your eyeball is shorter than normal, and that causes the image to fall behind the retina, right? So it causes the image to fall behind the retina because your eyeball is shorter than normal, and your lens is failing to become more convex, right? And that creates a blurry vision. So how can we fix long-sightedness? So let's look at the treatment. So when it comes to the treatment, right, we treat it with convex lenses. Remember, when it comes to short-sightedness, we treat it with concave, but when it comes to this one, we treat it with convex. So it means, what does convex mean? It means that it curves outwards. You can see curves outwards, or you can say biconvex lenses, right? So the biconvex lenses will do what? They'll bend the light inwards, thus focusing the image on you, directly on your retina. So that's how we fix long-sightedness. So let's look at astigmatism. Astigmatism, our third defect. So astigmatism is when your your lens, right, is unevenly rounded. So it's unevenly rounded, or it's not equally rounded, right? Remember, for a lens to focus the light on your retina, it needs to be evenly rounded. It needs to be biconvex, right? And when it's unevenly rounded, it will refract light uh, on different focal points on your retina. You'll focus the light on different focal points on your retina. Can you see? So it's refracting the light on different focal points, right? Which will create a blurry picture. As you can see here, you have multiple focal points, right? Or your cornea, right, might have an uneven, right? It's not equally rounded. Remember, your cornea also it helps in the refraction of light, rather, right? It helps in the refraction of light, and when it's not equally rounded, it will lead to that problem. Okay, let's go to our final disease or defect of the eye. So our final defect is cataracts, right? So what are cataracts? So cataracts is the clouding of your lens, right? So can you see that your lens, there's a clouding uh, in your lens there, right? What causes that clouding, right? So it's due to the inactivity of the protein. So denaturing means that it's the inactivity of the protein. So the protein is not active, it's not working, it's not functional, right? And it's caused by what? Remember, your lens it needs to be transparent in order to allow light to pass through and enter your retina. So it needs to be transparent. Does that make sense? So what causes this clouding? It might be caused by aging or chronic exposure to ultraviolet rays or due to physical trauma, right? Or trauma just in general, right? Okay, then lastly, how can we fix cataracts? What's the treatment for cataracts? So the lens can be removed, right? The lens can be removed and a synthetic lens can be inserted. So we can treat it with a synthetic lens, right? Let me go back to astigmatism because we didn't include treatment. So how can we treat astigmatism, right? It includes so the treatment includes spectacles or contact lenses, or we can do a laser therapy, right? So there are three possible treatments when it comes to astigmatism. Okay, so these are activities. I think we are done explaining. In the next, on our next video, we'll be explaining the human ear.